So today we're looking at the law of cosines. The law of cosines is looking at if we have a side angle side case or a side. So remember, the side angle side was the very last problem of your guys' last homework where there was all of that yucky work that you guys had to do to solve it, right? So ideally, we don't want to have to go through all of that just to solve a side angle side. So today, the law of cosines is a much quicker method towards this problem. We are also going to look at two different ways to find the areas of triangles, one in the side angle side case and one in the side case. All right, don't write this part down. You already have this slide from before. These were the two cases that we just finished working on. So any two angles in a side combination and the bad word combination. We use that law of sines for each of those, right? Now we're looking at the side angle side and the side. That's going to use law of cosines. So one more time, which cases are we focusing on today? Side angle side and side. Yeah, just be aware of, because what you need to do once I put this all together, on the quiz, is you need to be able to look at a problem and decide which method you need to use. So you need to see, am I in one of these cases, or am I angle side, angle, or angle side. That would be a different method. All right, so the first thing you guys need to be aware of are side length restrictions. So if you're given all three sides for a triangle, you need to check to see if it's even possible for that triangle to be formed. So if you're looking here, notice that I've got a long side and then I've got two shorter sides, right? If these two shorter sides add up to be less than the longer side, is it any way for these two sides to ever close and make a triangle? No. Like if you picture this swinging down and this swinging down, they're never going to touch and they're just going to end up falling on this line, right? Even if they add up to be exactly equal to this side, what that would mean is that they hinge down to land exactly on the line, but still don't form a triangle. So what we really need is for these two sides to add together to be longer than the third side so that they end up hinging up on each other and forming a triangle. Otherwise, there won't be one. So it's easiest just to check to see if the two smallest sides add to be greater than the longest side. Notice this does not say greater than or equal to, strictly greater than the longest side. Okay, so we have the law of cosines, which can be used for a side case or a side angle side. Notice that each of these parts right here, these look kind of like Pythagorean theorem, right? Since we're assuming that we don't have a right triangle, it doesn't matter which side you put over here. It doesn't have to be a hypotenuse because in a non-right triangle, you don't even have a hypotenuse, right? So what you end up with is you end up setting up something that looks like Pythagorean theorem. Doesn't matter which side you put by itself, as long as then after the Pythagorean theorem part you put minus 2 times the product of the two sides that are added together times the cosine of the angle that's opposite of the lone side. And again, it could be any of these ones. You just need to look at your situation and see what works best for you. Okay, so let's take a look at an example. Yes, you will have some word problems, so let's practice them. This is actually quite a pretty simple drawing. So for this one, you've got two boats that are leaving the same harbor at the same time, traveling on courses that make an angle of 82 degrees and 20 minutes between them. And they're just traveling in a straight line in those directions from each other. When the slower boat has traveled 62.5 kilometers, the fast one has traveled 79.4 kilometers. At that particular point in time, what is the distance between the boats? So do I have to worry about northeast, southwest, anything right now? Yes, no? No, I don't, right? All I have to worry about is that they've left a harbor, so here's my harbor. I have one boat that has traveled further in one direction. I have another boat that's traveling not in the same direction. What do I know about the direction, though? How can I figure out where to start drawing this guy? Uh-oh, did I lose you guys? Can you see that? Oh, it doesn't show you my drawing. All right. So what angle do I have to draw here? How much? 82 degrees, right? Ish, 82 degrees and something else. So I know that there is an 82 degree and 20-second angle between these boats, but do I really want to keep it in terms of minutes? I want to write this as, whoa, not that, that's for sure. Hold on. Okay, I want to write this as 82 degrees, and then I want to write it either as a decimal or a fraction, right? So how would I determine the decimal form of this? It would be 82 and 1/3. Does 1/3 make a perfect fraction? So instead of writing it as 0.33 repeating, I'm actually going to write it as 82 and 1/3 so that I can keep it exact degrees. Okay, my shorter boat has traveled how far? Okay, 62.5 kilometers. My longer boat has traveled, or my faster boat has traveled 79.4 kilometers. So what I'm looking for is at that moment that they're that far apart from each other, I would like to know what is the distance between the two boats. So ultimately I'm going to label this distance as x, and that's what I'm trying to find. How do I do this? So first of all, you have to first determine, obviously we're in the law of cosines section, so you know that you're going to be using law of cosines, but if this was on a quiz, how would you know that you were using law of cosines instead of law of sines? Yeah, you have a side, angle, side combination. If you tried to set up law of sines, you would run into problems real fast, and that would be a hint that you would try law of cosines. Okay, so if I have this side angle side business, I can set up something that looks like Pythagorean theorem, right? So it's going to look like x squared equals, can you help me out? Yep, 79.4 squared. So at this point I should be writing something that looks like Pythagorean theorem plus 62.5 squared. Notice that that really looks like Pythagorean theorem, right? But since that's not a perfect right triangle, I can't actually use Pythagorean theorem, so what do I have to add on to this? Right, minus 2 times each of those things, the 79.4 not squared times the 62.5 not squared, and then times cosine of 82 1/3 degrees, right? So this is all something that you just punch out on your calculator. Make sure that you're in degree mode. And over here, what I would do is you can either write it as an improper fraction, or you can just do 82 plus 1/3 to make that be exact. All right, so let's go ahead and calculate that, see what we get. So we get that x squared, when you work out that whole entire right-hand side, you should get 8,886 point, and then it's 519, blah, 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 right? Am I going to round this mid-problem? No, I won't round it until my final answer. But that's pretty easy because all I have to do to finish this to find x is to take the square root, right? And then I get that x equals, what is the square root of that? 94 point, and now we can go ahead and round it. I'll round it to the nearest thousandth, so I'll do 268. You'll just read the problem for what to round to. But that's, and I should be using better notation. This is technically an approximation. So I should do approximately. And have we answered the question? Yes, we have, so we're done. All right, next question. This time, rather than giving you a word problem, I've just given you certain pieces. What combination do you have here? Of three things. What three things do you have? Yeah, you've got side, side, side. That tells you, remember, side, side, side should always be solved with law of cosines. So you know you're doing law of cosines again, except for this time it's going to be the angle that you don't know. In that very last bit, when you take the cosine of an angle, that's going to be the part that you leave unknown. So let's start setting this up. Does it matter which side I put on the left-hand side of my equation to start the Pythagorean theorem looking part? Doesn't matter. So I'll just do 25. I'll do the 25.4 squared equals, and then I'll do 42.8 squared plus 59.3 squared. This is honestly, the next part is where a lot of people mess up. They're memorizing the formula. What is it? Minus 2, so a lot of people forget the 2. What else do I have to put? What? 42.8, yep. So the other two sides, 42.8 and the 59.3 times the cosine of, and which angle am I finding with this particular setup? A, because I have put my side A over here. That's the angle that I'm finding, right? So make sure that you're correctly labeling and putting the right angle in there. All right, so we have to do a little bit of work here. I'm going to write it all out so that we can see what's happening. What's 25.4 squared? That is 645.16. Equals, and then I'm going to do both the 42.8 squared and add it to the 59.3 squared. And I'm getting 5,348, bless you, 348.33. And then the next part that I still have to do is minus all of this stuff. Notice that I didn't condense all of that because can I include this minus stuff with this when I have a cosine of A attached? No, I cannot. So this stuff has to kind of stay as its own separate term. So the 2 times the 42.8 times the 59.3 has to remain separate. That's going to be 5,076.08. And that is still times the cosine of angle A. So now I have some pretty easy work. I can just subtract this 5,000 stuff off of the 645. So I've got 645.16 minus 5,348.33. So on the other side, I've got negative 4,703.17. And that still equals the negative 5,076.08 cosine of A. Divide out by the 5,000 stuff. And we get approximately, and at this point I have a decimal that I can't write exactly, so I'm going to have to use approximately, 0.9265, blah, blah, blah. That's approximately the cosine of angle A. So how do I find A? Yep. Go ahead and take the inverse cosine. Make sure you're using the whole entire decimal string that's on your calculator. Don't ever round if it's possible for you to avoid it. So I'm going to use that whole entire thing, second cosine inverse. I get 22, and now I can round because I finally have the angle measure, right? And that's my end goal. So now I can round to 22.09. Or I guess if I'm rounding to the nearest hundredth, it would round up to 10 degrees. Okay, that's only one angle though, right? So I still need to find another angle. There are a couple of different ways that you can do it. You can either do another law of cosine and just kind of swap out which sides you're putting where, right? Or at this point, do I have enough information that I can do law of sines? And is law of sines a little bit easier? Less work, right? So at this point, what I would do is probably law of sines to find my angle B, let's say. So if I wanted to find angle B, I would do the setup, the sine of B over little b, which is 42.8, equals, and which other combination am I going to have to use, the A's or the C's? A's, but only because I actually know angle A now, right? So I would have to do the sine of, now am I going to use the 22.10 or am I going to hang on to what the string on my calculator? String on my calculator, absolutely. So I'm actually going to be using the thing that looks like 22.098 blah, 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 all over A, which is 25.4. So to solve this, all that I have to do is take the 42.8, move it up here, and then the other thing that I'm going to have to end up doing, once I know this value, is I'm going to have to end up doing the sine inverse. But let's first calculate this. So I have sine of my answer from before, end my parentheses, times 42.8 divided by 25.4, and I'm getting that the sine of B should be approximately, not exactly, but approximately 0.633, 33, and then blah, blah, blah. So how do I solve for that? Yep, inverse sine of that stuff. And again, use the exact string on your calculator. So I'm going to end up getting that B, and then you can round it to the nearest hundredth once you're at that point. So I got 39.34 about. Am I done solving the triangle? I've got this B angle and I've got this A angle. What am I missing? How can I find C? At this point, what can I do? Just subtract the two angles you know from 180, right? That part, we can now use the rounded values at this point because those two are close enough and we need to add them to 180. So I can do 180 minus my 22.10 minus my 39.34. Somebody who's typed that out, can you help me? It's what? 118.56. And I also, to use correct notation, this isn't exact, right? It's just an approximation, so I really should be using approximate signs the whole way. Okay? So that's my angle C. Am I done solving this now? Yeah, I know all three sides and I know all three angles. Are there any questions about how to use the law of cosines given three sides or the law of cosines given side angle side? We good? Okay, so now we have to start looking at how do we find the areas of things. We have got two different formulas, side angle side, and we'll have one for side, side, side. So if you know two sides and the angle in between those two sides, so in other words, notice that I don't have two sides and then one of their opposite sides. It's a BC and an angle A combination, or an AC angle B combination, or blah, blah, right? You get it. It looks very similar to what we know the area of any triangle to be. Half of, normally we'd have base times height, but now we're saying, well, I don't need to take a perpendicular base times height. I can find this without having to draw a right triangle and do the height. That's what we're avoiding here. So what I can do is 1/2 of any two sides times the sine of the angle in between, if I know it. Okay? The other formula is for a side-side-side combination. For this one, you have to do kind of a mid-step. You have to find the semi-perimeter. The semi-perimeter is exactly what it sounds like. It's half of the perimeter. So add up all the sides, take half of it. Once you know the semi-perimeter, the area of the triangle can be calculated by taking the square root of that semi-perimeter times these factors where it's the semi-perimeter minus each of the sides separately. The most commonly forgotten part of this formula is this little s out front. Most people will remember all of this and then forget that there is just a lone s out front. So make sure you're not forgetting that. So let's look at an example. This one says the distance as the crow flies from Chicago to St. Louis is 662, from St. Louis to New Orleans is 599, and from New Orleans to Chicago is 834. What is the area of the triangular region having these three cities as the vertices? So the first thing we need to do is draw a little sketch of what's happening here. So kind of just as best as I can, I've got from Chicago to St. Louis. What's the distance of that? Yep, that distance is 262. The distance from St. Louis to New Orleans, what's that? 599? Okay. And then the distance from New Orleans to Chicago? 834. Yep. All right. So I know all three side lengths, and I want to find the area of this region in here. Which formula do I use? The what? So I use the one with the semi-perimeter, and it's called Huron's formula, right? So yeah, the first thing I have to do is find that semi-perimeter, which is S is equal to half of all of my sides added together, which is going to be 262 plus 599 plus 834. All right, let's calculate that, see what we get. So we should get that this semi-perimeter here is equal to 847.5. How do I use that? What's the actual, because remember, I'm not looking for the semi-perimeter overall, I'm actually looking for the area of the triangle, is what I really want. What's that formula? Square root of, yeah, S times S minus, and what's my A value? 262 times S minus 599 times S minus 834. Notice that I've been using S so that I don't have to write this out so big. That's fine, because I have told my audience what S is, right? So they can kind of figure out what I'm plugging in here. Now what you need to do is actually plug this all in. Go ahead and use the S value that you know, all right? And you can go straight to the answer on this one. Just punch it into your calculator. You guys should get, once you calculate that whole thing out, approximately 40,800.3 square miles squared, right? Or squared miles, because we're talking about area. Are there any questions on how to find that area? No? Okay, we've got one more example, and then you are done with Chapter 5's lessons. How exciting. All right. For this example, I want you to find the area of a regular pentagon circumscribed about a circle of radius 12 inches. Now, you guys probably remember from geometry, maybe, that was a couple years ago, I guess, but we used to find the area of polygons by cutting it up into little triangles and finding the area of each triangle, blah, 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 right? And it was a lot of work. Do you guys remember that? But, what?
They just gave us the formula and we just plugged it in.
Oh, really? Well, that's not quite how... For the volume, sure, but for the area, it's different for every single type of polygon. So you'd have to do, it'd be quite the formula. But anyway, we've got a pretty straightforward way of doing this now with the area formulas that I've just given you. It's a lot easier to find the area of the triangle now. So let's take a look at this problem. You guys have, you're told that you have a regular pentagon circumscribed about a circle. So the first thing we need to do is draw a circle. All right, and I'm kind of down really far, but that's okay. Circumscribed, does that mean that the pentagon goes inside, or does it mean that it goes outside? Nope. It says that the regular pentagon is circumscribed about a circle. If I said it was inscribed in a circle, then it would go in. When I say that the pentagon is circumscribed about a circle, I actually mean, and you're going to get both types, so make sure that you're paying attention to whether you have inscribed or circumscribed. When I say circumscribed, I actually mean this version. And I'm going to do the best I can. It's not going to be perfect, but what? Not really. It's about as good as it's going to get, is what it is. All right. So I need to find the area of the pentagon, not the area of the circle. But I am given that the radius is what? What is the radius of this thing? I am told that the radius is 12, right? So I'm going to make use of that. Now, how am I going to find this area? I'm going to find it by looking at this triangle and solving from there. Okay? So the first thing that I need to do, or what's the very first thing about that triangle that I can find? What's the very first piece of information that I can easily find? The angle, right? So keep in mind that around the center, how many degrees are around the whole circle? How many of these little triangles would fit around the entire pentagon? 10 of them. So what is 360 divided by 10? 36 degrees is this angle measure. All right? Now, in order for me to be able to find the area of this using one of our formulas, I need a side angle side combination, right? I can find the hypotenuse here pretty easily using SOHCAHTOA, can't I? So I can find the hypotenuse by noticing that I've got an adjacent and a hypotenuse, so that would be the cosine, right? Cosine of 36 degrees would be equal to 12 over my hypotenuse. So my hypotenuse would be equal to 12 over the cosine of 36. All right, so this is my h value, right? Now, if I was using the formula for the area of the triangle that I just taught you guys, we would be doing 1/2 of the two sides that you know. So the 12 times the 12 over cosine of 36, right? And then we would be multiplying that by the sine of 36, wouldn't we? What? So this is that 1/2 of the two sides times the sine of the angle in between. That was the first area formula I gave you guys today. Right? Do you see what I'm looking at, Lauren? Okay. No, you're fine. So then basically what ends up happening, if you simplify this down really fast, you have 12 times 12 is 144, but half of 144 is 72. You've got sine of 36 over the cosine of 36, which is just the tangent of 36. Calculate that, but to find the area of the entire pentagon, how many of those little triangles do you have? So you would be taking 10 times that area. And then you could just punch that out on your calculator really fast. You should get 523.11. Now Sam was bringing up, and he's correct, that you could technically use the tangent right off the bat to find the base, do 1/2 base times height, and then multiply that area by 10. It'll, either way, it's going to get you the same place. Now let me ask you this. Let's backtrack really fast. Does everyone have this? Yeah? Okay, so let's go back and pretend that, let's say that I had said, instead of circumscribed, let's say that I had said inscribed. Then it would look like, and this is where that formula we were just using actually comes in handier and where you wouldn't really do it a different way. So for this one, inscribed means going around the inside of the circle. Oh no. Shh, I'll get there. Okay. All right. This is when it's inscribed. Yes, it's a little lopsided, but we're assuming that it's regular. This time it's actually a lot easier because when I start to draw the radius, notice that I can draw a triangle straight off of the radius and find two sides of that triangle right away, right? What is this angle measure this time? So this time we're not dividing by 10 because I've made a bigger triangle, right? I didn't draw the little right triangle. So how many of those triangles fit around? So what's 360 divided by 5? 72 degrees. So now can you guys use that formula I just gave you right off the bat? Yeah. So this time it's actually way easier to do this way. Area of the triangle equals 1/2 of the two sides multiplied together times the sine of the angle in between. Okay? So that ends up being 12 times 12 is 144 divided by 2 is 72, sine of 72. And then to find the total area of the pentagon, what would you guys do? You have 5 of those. So you would be doing 5 times 72, sine of 72. Calculate that. You get about 342.38. So which version is easier? Definitely the inscribed, right? This is far easier than the circumscribed. In the circumscribed, it might not be any more efficient to use this formula than your regular old 1/2 base times height. In this case, it is definitely far more efficient to do this, right? Are there any questions, Shane?
Are we going to have to memorize all of these formulas?
Yes, you are. All right. Here's your slide. Yeah, guys, with the formulas, you already know law of sines. The law of cosines is the one that looks almost identical, well, not almost identical, but it follows the Pythagorean theorem very similarly. Those two area formulas are not that hard to memorize. So you do need to know those on your own, okay? This is your homework. It will be due on Thursday. We'll check it before we do the quiz. From this section, what you guys just need to be able to do, and it's actually, this section, I hope you agree, was much easier even than the law of sines because you didn't have those weird like 0, 1, or 2 triangle cases. It was, you can either solve it or you can't, right? And that was it. So this should be, as long as you do your homework, you should be fine on the quiz if you know the formulas.